So welcome from my side. As Kurt has been telling you, it's a recurring one, and the motivation for today's talk already has been given for me like 2 years ago when I was attending the user group meeting in Denver, and there was a presentation on from the University of Miami where they were using big data workflows on their HPC system, and that was kind of really a takeaway for me to look into that. And what I'm going to present to you today is what we did in the last couple of months with respect to bringing our HPC system more towards big data. And I want to acknowledge the two colleagues that I did that together. And since I'm a chemist and we are a chemical company, as we'll show you in a second or so, everyone has a PhD because that's the people that we are hiring. And if they don't have a PhD, at least they have an IT background. So I'm a chemist, and Thorsten is the only one with an IT background there. So as I've been mentioning, BASF is a chemical company. We are doing a lot of different products in the world, and our main customers, or one of the largest customer base, is really with automotive OEMs, where we provide all different kinds of products inside. And we used to make the joke that whenever you enter a German car, try to not touch any BASF products, which will give you really a hard time. There. One of the more recent ones that you have had in the media is agricultural solutions. So due to Bayer acquisition of Monsanto, Bayer had to lay off parts of their business, and that was gratefully accepted by us for a good price, I think so. And we have now also a much stronger position in the agricultural business, and that's it for the product portfolio. So I'm with BASF Research, and you've seen numbers on how many percent of the annual budget are spent in research. So I wish I could say it's going to be like 16% with DDN. So for us it's 3%, but it's nevertheless $2 billion a year. And our mission here from digitalization in R&D is to really boost the efficiency of our research. And we have lots of different digital capabilities where HPC and scientific computing is not the least of all. And yeah, that's where I am located in a company, and what I want to tell you a little bit more in the next couple of minutes. Supercomputing, BASF has a long history. I tried to compile the data that is publicly available. So it reaches back until 1996. So that's an 8-core system down there, which made it into the top 100 that was in there. Yeah, 8 cores, never mind. So we were a little bit losing track here because that's a logarithmic scale, and if this opens up like a scissor, that's not good. But 2 years ago, we were really catching up with a top 100 system, which was also then the biggest system in chemical industry. And since I haven't been over there to the announcement of Top 500, I can't tell you whether it's still the biggest system in chemical industry or not. I need to check afterwards. So what we have here, you can read it yourself. The important thing today is that we are based on a GRIDScalar architecture, which has like 5 petabytes. And I want to thank my previous speakers for setting already the setup, because that would more or less apply to our system too. Yeah. So all the nasty things like AFM and what you need to do there to move the data around. So. Since we have 20 years plus of experience in HPC, and I did my first contact with HPC 20 years ago myself, we have a lot of people that are really strong in HPC, but from time to time, to really address the problems that we are facing in making our research more efficient, is that big data workflows are somehow creeping in, and you need to get also these done. So running a Hadoop system, I can tell you from my own experience, is not for the faint at heart. So it's really at another level of maturity compared to HPC. And I had the pleasure to also run a big data project in the past before I switched again back to HPC. And this big data project now is what we call our R&D data lake. So very difficult, and also if you think about the recent developments in the Hadoop ecosystem with Cloudera and MapR, kind of struggling at the moment in the market, we looked at how can we get our users that are used to an HPC environment, which is also much more mature inside a company, to really get big data workflows running. So the one thing about Hadoop that we envy the most is Spark, because Spark is a wonderful computation engine, and it does the same for you in big data that MPI does for compute parts. So it's very good to use, very, very low barrier of entering it, and you don't need a Hadoop system to run Spark. And that's why I want to tell you a little bit here is that we are running Spark jobs regularly now in production use on our HPC system. So how it works is that you have a Spark job that is prepared, and you put that into the HPC queuing system, and it uses the existing global storage. So you don't need to spend an additional HDFS system. And we have two examples I'm allowed to talk about because that's a very competitive area, and we are much less disclosed than what we do in simulation here. So one thing is we are doing image analysis where you are going to train the classifiers on the HPC system. So you have AI and HPC, and once you have the classifier, you need to really apply this classifier to lots of images to do the analysis of the images. So that's a big data one. So if you fill out these bingo sheets, I have HPC, AI, and big data in one talk. The second example is that we are also doing full text mining. We have lots of documents, obviously, swirling around in the company. So 150 years, obviously, the company generates kind of a lot of data. And what we are using is Apache Tika to really do full text analysis and then also document classification so that you can more or less tell what in this data swamp that you have, because it's never a lake, it's more like a swamp. You can find more or less the classification where these documents should belong to. Yeah? So the next slide is a technical one, because I wanted to show you that running Spark with PBS is really straightforward. You have a very complicated installation process, which is you download the file and untar it, and that's it. Then what you need to do is you need to spin up a Spark cluster on your own, really depending on your setup. So we don't have like 24/7 Spark usage, which means we spawning that on demand. And I've brought here a script snippet that actually works and tells you how to integrate Spark with your environment, because everything has been prepared by the Spark authors. It's just setting the right variables in the environment. Very straightforward. So I wish more people were using that. That's why. So the nice thing is this Spark job, and I've done a little bit of them myself, has the complete API available. So with the exception of HDFS protocol, you have everything there. You can use it however you want to use it and however you would run that into in a Hadoop system. You see here, it's just saving the files without the HDF URL. Obviously, multi-node jobs need a global file system, but you have that already on an HPC system. So no need for HDFS once again. Whatever you have, we have a GPFS underlying there. And I'm happy to learn today that Lustre is also going towards HDFS connectors. So the other thing I wanted to show you is the other way around. So I've shown you how to bring big data workflows into an HPC system. So, but how about connecting HPC system and a data lake? And that's shown here is that we did, and that's not in production yet, so it's been kind of a POC that we did nevertheless successfully, is with the HDFS transparency that comes with spectrum scale. You can really bring your data from the HPC system in a data lake. So that's another use case. What we have here is our DDN system, and then we have the cluster expert services running on a couple of nodes, and those are really providing HDFS protocol and can be consumed here in the data lake by a namespace. And I just put here like a placeholder there. And the question is, how do I integrate those data in a data lake? Yeah? Then comes into place ViewFS, which is also a standard component of every data lake, at least if you use the Hortonworks, HTTP, or Cloudera. And then VUFS is simply, it's a mount point. Every one of you knows what a mount point is. And you just, by the path that you choose your files to store at, you choose either the HPC system or whatever local storage you have in your data lake. So, since I said it's a POC, not in production yet, some benchmarks, and it's been running on just one compute node, was a small benchmark. What you see here is that more or less you get the performance out that the network is doing the bandwidth limitation there. So no big performance impact for running transparency there, and it worked out really smooth there. So that's what I wanted to tell you, and I think I made up a little bit with the time, and I'm happy looking for questions.
Dean, yeah.
Quick question. We have another customer that's looking at doing just what you described, and they wanted to know, they were struggling with how to do a backup environment with HDFS through the global file system, because have you thought about that?
Yeah, that kept me awake at nights for a couple of years. So we decided not to do a backup of our data lake.
That's what they decided too.
Yes, because everything else would be insane. So there's no multi-site spanning. Forget about that.
They were worried too about the synchronization of apps in a Spark or a Hadoop environment. You know, you've got databases that run with other apps, and they're worried if they captured a point in time, it would be out of sync. And they,
exactly, those were the worries that we had, and we just didn't deem it worth to invest that couple of million euros with few effect in the end.
Okay, thank you.
Well, same conclusion on our side.
Yep, good, thank you.
So we also try to explain to customers they can run Spark workflows directly on file systems. But are there applications in the HDFS world which don't translate well onto a GPFS adapter?
Not yet. So as I said, it's a POC stage. We haven't done this in production yet, and so from the maturity, that if you compare maturity in HPC and big data that we have, so our big data workloads are not that heavy as our HPC workloads. So we have never ever experienced any performance issues in the big data workloads that we are running. So didn't make a problem at our side yet.
Okay, thanks so much.